world's oldest fungi, found in fossils, may rewrite Earth's early history. Fungal fossils, hundreds of millions of years older than previously known, shed light on the evolution of fungi, plants, and the planet's surface. A technique called confocal laser scanning fluorescence microscopy uses a dye that binds to chitin, unique to fungi, seen here glowing green on the exterior of the fungal filaments, in a fossil dating to at least 715 million years ago. From Bonneville et al. 2020, Molecular Identification of Fungi Microfossils in a Neoproterozoic Shale Rock. Science advances. It's hard to overestimate the importance of fungi, and easy to understate how little we know about them. Scientists have described a little over 1 lakh different species, while estimating that there may be as many as 3.8 million. Fungi do many unseen and unglamorous tasks. They break down countless amounts of detritus and dead things, and they cycle nutrients throughout the environment, without which the world would cease to function. They also make plant life possible. Vast webs of fungi stretch through soil, transferring chemical signals, food, and water. Not to mention their more fun roles, like fermentation, which creates alcohol, leavened bread, and much more. Much of the distant history of fungi remains a mystery, however. While they branched off from animals more than 1 billion years ago, making them more closely related to us than plants are, there is a large gap in the fossil record. For hundreds of millions of years, they simply vanished to time. 2 recent papers, however, have shed light on what fungi were up to before 400 million years ago, the age of the oldest, non-controversial fungal fossils. In May, a team of researchers published a study in Nature suggesting that a 1 billion-year-old fossil from the Canadian Arctic was that of a microscopic fungus. And today, another group was shown, using a more rigorous set of chemical tests, that a fossil dating back at least 715 million years is indeed the branching of filamentous fungi, in a paper published in Science Advances. In the latter paper, Steve Bonneville and colleagues examined a fossil from a piece of shale originating in the Democratic Republic of the Congo that dates to between 715 and 810 million years ago. Bonneville, a researcher at Université Libre de Bruxelles, Belgium, says that he's been working on this rock for more than a decade. This will change our understanding, Bonneville says, of how the land surface evolved, and how plants and fungi came about. It's fascinating to think that, even at this time, fungi were already there. Fossilized fungal filaments are visible in the shale, found in the Democratic Republic of the Congo. Various microorganisms can create similar filaments, but they do not create chitin. From Bonneville et al. 2020, Molecular Identification of Fungi Microfossils in a Neoproterozoic Shale Rock. Science Advances. doi. 10.1126 SCIADVAAX 7599. This work is licensed under CC by NC. When Bonneville was first told by others that it was fungi, he remembers saying, "That's impossible, it's too old," but years of work have shown otherwise. Bonneville used 3 techniques to show that the filaments, which extend like a woven mesh throughout, contain a material called chitin on their exterior, a clear sign of a fungus. Few organisms create chitin, a polysaccharide. And those that don't form these kinds of filaments, Bonneville says. One detection technique employs a fluorescent dye to bind to chitin. The other 2 involve the use of a synchrotron, a particle accelerator that bombards material with fast-moving atoms to learn more about the sample's chemical makeup. All of these methods provided clear evidence of chitin in the fossil's filamentous networks, Bonneville says. The authors used an impressive combination of chemical techniques that converge towards the same result and in this way make the result quite convincing, says Christine Stroludarin, a researcher at London's Natural History Museum who wasn't involved in the paper. When this weft of fungi lived, in the Neoproterozoic era, the land was relatively bare, likely containing only bacteria, perhaps coating the ground in biofilms. Land plants didn't come onto the scene until about 300 million years later. On the supercontinent Rodinia, this ancient fungi might likely lived in sediment, and fed on decaying organic matter, perhaps that of cyanobacteria and green algae, Bonneville says. It probably lived along the edge of a lake, or perhaps just under the water, he adds, and became mineralized after being covered by other layers of sediments. It may be that even at this early date, fungi was behaving symbiotically with photosynthetic bacteria, Bonneville says, though Stralodarine clarifies that these would not have been the same type of fungi which currently symbiotically interact with land plants in soil. If you put fungi and green algae together in a liquid, after a couple of weeks, they'll form some kind of cooperative relationship together, Bonneville says. How trees secretly talk to each other in the forest and even earlier origin for fungi-plant symbiosis could teach us much about the evolution of both groups, as well as lichen, a hardy composite organism comprised of a pairing of the two that can survive in Earth's most extreme environments. Early fungi would have also helped pave the way for land plants. Without them to break down detritus and release nutrients, it would be difficult for photosynthetic organisms to extract anything from the ground, Bonneville says. Because of their unique ability to access nutrients in minerals and, at the same, to create symbiosis with the first plants, they were the key to this major evolutionary transition, he says, the spreading of plants across the earth. But it's too early to say much more about the implications of the study because they are so new, and remain controversial. Any one test cannot conclusively prove that material so old is made of chitin, Stralodarine says, as in the case of the Nature paper, which only used one technique, and more studies are needed to understand what was going on at the time, she adds. Please save trees and nature, please subscribe my channel. Thank you.